Let's run the client code. So this is undefined, but we are getting a result over here. And now let's go one layer deeper down and let's check that if our client.cpp is running fine. Hit on to the client.cpp. So first of all, let's turn the server on. Let now this is the client. Yeah, so the client is working fine. We are getting this data correctly. The buffer that we're obtaining is correct. And after this, it is also closing the connection. So that is fine. What we So, hi everyone. In this video, we will be building our own application layer protocol, just like HTTP, that we'll be using to communicate between two different entities and so on. So, what is basically an application layer protocol? So, all of us know about the TCP IP model that works in networking. So, basically, in the TCP IP model, you have all of these things. You have these four layers: network access layer, network layer, transport, and the application layer. So basically, we are going to build a protocol that would allow us to communicate with the application in the application layer, and further down the line, everything else from the transport layer, network, and network access layer is obviously it's already set up. So we just have to set up an application layer protocol, and which will help us to communicate from one application on one machine to other application on another machine. So basically, what happens is, let's these are the two different entities that are going to communicate with each other. So these are basically two different applications or two different processes that are running. So we just want one of the processes to connect with on to the other processes. So that's what basically our browser does. Whenever you hit onto some API or go onto some website, it's just that the browser connects to the process on that endpoint. Yeah. So whenever you communicate with the application layer, so let's say you you type in something from here, and let's say you send some data from here to the application layer accepts that data in some format that is standardized. So that standardized format, let's say it can be any protocol. It can be a WebSocket protocol or an HTTP protocol or anything of that sort. So these protocols are standardized and they have their own properties that you need to send with them. There are some attributes that you need to send. So if you, let's say, if you have an HTTP protocol, there are different attributes that you'll be sending with it. Maybe you have the request body, then you will be having the authorization headers. Let's say you have headers. In headers, there are many different things. Then you can send content type, which might be JSON or multimedia content type or anything of that sort. So there are many different attributes that an HTTP request has. So these are standard attributes defined under the HTTP protocol. For the application layer to communicate with the transport layer, this protocol is something that everybody has signed up to. So if you are signed up to this protocol, you need to follow the rules that this protocol has. So what we'll be doing is we'll try to create our own protocol and let's see how it goes. So firstly, in the application layer, you have these protocols like HTTP and stuff, but what about the transport layer? So whenever the data travels from the application layer to the transport, then to the network access, and then to the network access layer of the other entity, and further up the way to the application layer, and then it is displayed to the user. So the thing that we can do is we need to build something on top of the transport layer. So basically what happens is whenever you send a request from application layer, let's say you send something in this protocol in this format of HTTP, and when you send this, the transport layer does not directly accept it because it has its own protocols. The transport layer has its own protocols of communicating with other layers and dealing with any information that it gets. So down down the layer, as you go down the layers, every time the information is going to get divided into certain segments. Let's say in the application layer you have the HTTP protocol as a whole, you have the request as a whole. In the transport layer, as you send it to the transport layer, it will break it down into TCP packets. And once you send it down to the network layer, these packets will be broken down further again. And once you send it to the network access layer, it will be broken down further again, maybe into bits and bytes, which can be transferred physically as well. So this is how basic networking works. And That is why what we are going to do is we don't have to deal with the network and network access layer. We just have to deal with the transport layer. So to create an application protocol of our own, application layer protocol of our own, what we need is we just need to have something uh, on top of this transport layer that we could use. So first we need to access anything from the transport layer. So in the transport layer, the protocol that is being used is the TCP protocol. So what is a TCP protocol? So TCP is basically a transmission control protocol which enables communication, and it's a standard for communication between two different entities. So let's say if you send any data to the any data via TCP protocol directly, obviously that data, there might be some sensitive information as well. Along with that, for to access this data on the application layer, you need to parse this data according to what you have obtained, and for that you will be have to write code on the application layer. So today we don't do that. We just use Express or Spring Boot or anything or any backend stuff of that sort, and once you get the HTTP request, you can simply parse it down into the application. So it actually doesn't worries us or bothers us. So it's just as simple as that. You need to build something that works on top of TCP layer, and you can just access it onto the application layer easily for the developers as well as for users to use it. So in the transport layer, if you see, you will be dealing with TCP packets. So to do this, what we can do firstly is we need to connect these two transport layers. We don't care about what kind of data and how does the data travel through the network as well as the network access layer. So we just have to take care of the fact that we transfer data from this transport layer to the other transport layer, and on the application layer we'll figure out it on our own. So basically what we are going to do in the implementation is that we have this as the, let's say, we need to have a connection between these two layers. So that connection will be provided to us by a TCP socket. So we can write this code in C or C++ where we connect these two sockets. So we will be having a server and a client socket. The client will create its own socket on certain address. So the server will create its own socket on a certain address, and these two addresses will be same. So the socket will get connected, and a complete socket will be formed. So once this socket is formed, we can send data from one transport layer to the other transport layer. So this is how we will be doing for TCP. Now on top of this TCP, we have to create our own protocol at the application layer. Let's say this is our client, and okay, so what we can do here is that whenever the client sends some data, let's say from the application layer, we will be having a certain format that the client will have to abide by, and the server will also have to abide by. Both the parties will be agreeing on the fact that the format that we are receiving at the application layer will be certain sort. So let's say we have a protocol that we have built on our own, and that protocol is HTTP-R, let's say. We have certain rules of HTTPR. We have certain attributes that the HTTPR has to send. So we send all those attributes to the transport layer. At the transport layer, nobody cares about attributes and stuff. It's just simple data. All of these HTTPR data will be converted to some packets and in TCP packets that the transport layer can use and transport it to the other side. So nobody cares about what protocol has been used, what are the different attributes that are being used. So simply the HTTP-R protocol will connect to the transport layer. The transport layer will send this via TCP socket to the transport layer of the server. Once it is received at the server, we can access these packets. Once we access these packets on the application layer, we know that the server has agreed upon the fact that it will be using an HTTP-R protocol that is created by us. So the server will pass that data according to the protocol that we are using. And once that data is passed, we can use that data and display it to the user or do whatever you want to do with that data. So this is how basically we are going to go about this. Let's figure out along the way how we will implement this and what all different things we'll be using. So the basic thing that I can see here is that we will have on the application layer, let's say we have a Node.js application that is running. and through this Node.js application, we need to interact. We need to start networking basically. So for that and for TCP sockets, we won't be using Node.js because TCP sockets are a very low level thing, and these are near to the hardware, near to the operating system as well. So for that, for TCP sockets, we will be writing some code in C or C++, which the reason for that is the low level programming language allows us to get access to the system calls of the operating system. So that is why we will be using a low level programming language to create a TCP socket and transfer data through it. Now, how are we going to send the data from application layer to the TCP socket? Like, how are we going to execute the other program? For that, we will be using shell scripting, where we can trigger different programs uh, on the transport layer. In a real world scenario, maybe we can use something like WebAssembly or WebAssembly is this new technology. I mean, it's not new, but it's taking pace nowadays. So it's a type of thing where you can run C or C++ or any low-level language code into a browser. So WebAssembly is a basically a portable binary code format which executes programs of a very low-level language into your browser itself. So basically, it's mainly used for high performance stuff, but we can implement this here as well. We can reduce the overhead that is causing because of the shell scripts. If you reduce that overhead, it will really be something that can be implemented in real world scenarios. So currently we'll be using shell scripting, and so let's see how will our code look like, and how will the architecture of this be. Yeah, so let's say if we want to create a server, let's say you have to create an Express server. What we do basically is, firstly we import the Express library, then we create an app with we instantiate this Express, and now Express has the capability to provide us with many different functions. Like you have a get function, you have a post function. So what are these functions? These functions enable us to transfer data via HTTP from the application layer into the network or into onto the internet. So this is basically what Express does. Express is a library basically that provides us with many different functions that you can, with the help of which you can send data from application layer or from your application or from the process that you are running on your system to the other process on some other system or on the same system, anything of that sort. So we want to build something like this. So Express actually abstracts out the implementations of how this get and post request works and in what form are we sending this to the transport layer. And this is where we are going to work now. So we have to create some library of this sort, some functions that we will be exposing out to the user. So your users are uh, yeah, let's say developers who will develop browsers on top of this. So we have an express library that consists of different functions. We also need to create some library of this sort consisting of different functions, let's say, and we can directly connect to these functions from this library. So, and the library under the hood will take care of how it has to create a packet, in what format, how to abide by the format, and how to send it to the TCP socket, the transport layer. Okay, so let's see how we can do this. So first of all, we have this as a client, and the client has a process that is running on the system. So this is the application that is running, and using the application layer protocol, we need to send data to the client TCP socket, which further down the line connects the two transport layers. So this application will okay. So let's say the application is running in Node.js, and we send some data. And so if we send a message, that message we will have to send to the TCP socket. So for that, what we can do is we can create a TCP connection with the server, send the message and close the connection as well. So for that, we also will need to have uh, a server here. So this is our server, and on this server as well, we have an application that is running, which we call basically as the backend application, and a TCP socket as well. So we need to figure something out so that we can relay the data from these different layers to this application and then also get the response back. So for that, what we can do is firstly, let's say we have an application that is running on Node.js, and Node.js or JavaScript, or on the even if you are working with the browser, you'll be running a JavaScript. So let's say it runs a Node.js and you have a function, let's say send data. So whenever you trigger that function, send data, mm, okay, so let's say you have triggered a function called as send data. Okay, so this function send data will basically get will fetch the data that you have input, or the data that you want to send. It will fetch that data and call uh, call a shell script that consists of the TCP socket code. So in this function send data, I'll just write down what all things it will do. So firstly, it will take data, convert data to string, let's say, because we'll be transferring string overall. It will obviously be in a certain format, but basically, whenever the data transports to through all these layers, it is in the form of string because it is the simplest way you can do that. So in the send data function, you will have to convert data to a string. Once it converts to a string, trigger a shell script that connects to the server TCP socket and uh, and and add the string as argument to the script. So yeah, so this is how we are going to do. We'll trigger a shell script, and the shell script will contain something that will execute the code of TCP socket at the client. And once this is done, we can simply send this data to the TCP socket client function. Now we have another socket at the server side as well. This socket will be up and running by the time we do all of these connections. So this socket server has to be up and running before everything gets started. And once the TCP socket client sends data, you can send the data directly to TCP socket server once this data is obtained by the TCP socket. So whenever the socket client sends it to the socket server, it will be in the form of TCP packets, which will further down the line go via the network layer and network access layer, break down into bits and bytes, and then LM is received by the server. So we don't care about that. We just care about the TCP socket that we have formed, and at the server end, we just want it to be in the form of TCP packets. So once we receive this in the form of TCP packets, now we also have to pass this out onto the application layer so that the user can use, so that it is visible to the user. So how will we be doing this? So once you get it at the TCP socket server, this server will also have a shell script that will execute the uh, application file. So the application at the server side is also a Node.js application, let's say, and let's execute this Node.js application as a in the form of a script. So basically, what we can do is we can have the luxury of calling a wrapper function that consists of different methods. Let's say if you have an express, So this express is a wrapper that consists of get, post, and all these methods. So express might be a class or a module that consists of get, post, and all of these things. So obviously we can do the same thing here as well. At the application layer, we can have a wrapper or a class or a module, let's say, and we can call this module over here itself at the TCP socket server level, and that would do for us. But for now, first for that, we might need to have to use WebAssembly or native Node APIs, which can help us execute Node.js into C++ or C++ into Node.js. So for now, what we'll be doing is we'll be creating a shell script. Our main aim is to connect these two sockets, and on top of these sockets, create something that is of our own, a protocol that is of our own, and pass that data according to the way we set rules, and not rely on anything like HTTP or anything of that sort. So once the TCP socket server is executing, it has received data. Now again, it will run it will execute a shell script, and in this shell script, it will call this Node.js application, and the Node.js application will execute. Once the Node.js application executes and returns, the Node.js application will return some string or some data. That string will be taken up by the TCP socket server, sent back to the client, and then the send data function will return the third thing that send data function will do is return response. Fine. So, okay. So how can this be done? TCP socket server receives the data. Once it receives the data, I'll just mention something about this. So first is that the TCP socket server receives data. Once it receives data, initiate a shell script that runs Node.js application at the server, get a response from the Node.js application, and once you get that response, send the response back to the client, and that's it. So once you send the response back to the client, it will be the send data function will return that response to the application, and the client will receive the response as was requested. So yeah, so this is how the things are going to be once you once the TCP socket server receives data, it will trigger a shell script. Via this shell script, you will the application Node.js application will run. It will create a response. That response will be sent to the TCP socket server back, and the response that will be sent is will then be taken up and sent to the TCP socket client, and this further will be sent to the client side application, and this is nothing but the value of return value of send data function. Yeah, so this is how the flow is going to be. The name of our protocol is going to be HTTPR, and it will be a very simple protocol. We will not keep a lot of attributes, very simple attributes, and let's see.